So now that we've spent an entire lesson on naming different substances, whether they be ionic, covalent, contain a polyatomic ion, or perhaps an acid, we're going to see how we can react those substances and form different or new substances, which we'd also be able to name now. So there's 4 different types of reactions and how we can classify them. We have synthesis, decomposition, single displacement, and we're going to spend a little extra time on single displacement and double displacement. And as we go through all these different types, we'll see a couple of examples, and we're going to also review and touch on balancing those reactions. So a synthesis reaction is when you have 2 or more simple substances combining to form something that is more complex. So also known as an addition reaction because we're literally just adding things together. So if we want to show it kind of using not real examples, we have 2 different substances. They're simple. They combine to form a product that is more complex. 2 simple things, so just hydrogen gas, just oxygen gas, they'll combine and form one single more complex product. So our example here is not balanced. How to balance it when you have just H's and O's. My tip would be to go in alphabetical order. So depending on other classes, I'm sure you've met balancing before. Perhaps you've got strategies that work for you. I'm not telling you to do them any other way. Do whatever works for you, but I would go alphabetical order. So I have 2 hydrogens on the left side. I have 2 hydrogens on the right. They're good. I have 2 oxygens on the left side. I have 2 oxygens on the right. So our oxygens are not in balance. How I can correct that is I can put a big 2 in front, like I see here. That means now that I still have these 2 oxygens, and this 2 multiplies to this oxygen, making it also 2 oxygens. The thing is, when I added this 2, I also multiply hydrogen. I multiply everything that's behind it. So I now have 4 hydrogens instead of the 2 that I just had balanced. So I have to make sure I also have 2 times 2, 4 hydrogens on this side as well. So let's just double check. I have 4 hydrogens and 4 hydrogens, 2 oxygens, and 2 times that 1, 2 oxygens. We're good. So that's synthesis. 2 simple things combining to form one more complex thing. Sometimes combustion can be a type of synthesis reaction. So the reason why it's called something different is because we always need oxygen gas as one of the reactants to call it a combustion reaction. So we've got solid sulfur, a simple substance, oxygen gas, a simple substance. They combine to form one more complex substance, sulfur dioxide. We can check if it's balanced. We have 1 sulfur, 2 oxygens, 2 oxygens. We're good. So the reverse of a synthesis reaction is called a decomposition reaction. So that's when we have something that's more advanced, that complex thing that we had been making, and it breaks down into smaller, simpler substances. So this is honestly the exact same example, but we've done it backwards. Oh wait, I read this wrong. It's hydrogen peroxide now. We've got a 2. So we've got hydrogen peroxide. This is a more advanced molecule, and it's breaking down to its elements here, right? It's oxygen gas and that's not an element, into liquid water. I'm sorry. So we've got 2 simpler substances on this side and something more advanced, showing the normal pattern of a decomposition reaction. Let's check if it's balanced. We'll go alphabetical order again. 2 hydrogens, 2 hydrogens, and we've got 2 oxygens, and 2 plus 1, 3 oxygens. So it's really hard once you have an even and an odd number. If you are happy with using fractions, you could always put a half right here, which would make half of 2, 1 oxygen, and we'd have 1 oxygen here and 1 oxygen there, and we'd end up having 2 oxygens on either side. Most people don't like fractions, and that's totally fine too. I'd never force you to use one. So let's go back in time, and if we've got something where you have 2 of one of your atoms and then 3 of the other, like you're off by 1, put a 2 in front of something. Could be anything. We might have to change it down the road. Let's put a 2 in front of this. That's where this 2 comes from. And then let's balance from there. So we now have 4 hydrogens. Let's make sure we have 4 hydrogens on the other side by putting a 2. We now have 4 oxygens. This 2 is already here, by the way. And now we have 2 plus 2 more, 4 oxygens. So everything's balanced. We can see that if we were to divide everything by 2's, this would be a 1, this would be a half, and this would be a 1 again, just kind of how I said if you wanted to use fractions. So decomposition, the exact opposite of synthesis reaction. Single displacement. So single displacement is when 2 elements swap places to form a new product and element. So we have a compound plus an element, and on the other side of the arrow we have a new compound and a different lone element. The B and the C have swapped places. The A remains. Whatever has swapped places has to be the same type of element. So if B and C swap at the back of the compound, it must be a nonmetal. I believe our example is showing us, yes, metals instead. Okay, so we've got this kind of be our C, our element, and our AB, our compound. And then on the other side, NO3 is still part of a compound, but now it's bonded with Zn, which was its lone element before. And Pb, which was part of a compound, is now all out on its own. So Zn and Pb have swapped places. That's a single displacement. Zn has displaced Pb. NO3 has always been in a bond though. Zn and Pb are both metals, and that's why they swap each other out. NO3, a polyatomic, but made out of nonmetals, is our nonmetal here. It can't swap places with Zn. That's different stuff. It says it's already balanced. We can double check. We've got 1 Zn, 1 Zn, 1 Pb, 1 Pb, 2 NO3s, and 2 NO3s. So when I'm checking for single displacement reactions, I'll typically do the metals first, so like the Zn and Pb's, and then whatever the nonmetal or polyatomic is last. It's nicer to do polyatomics afterwards because that's a whole group you're looking at. Sometimes it's harder to balance when it's multiple different types of elements or atoms. So single displacement and double displacement are different because now we don't have any lone elements. Everything is a compound here. So you've got a compound plus another compound going to 2 different compounds we hadn't seen before. Notice that A and C are at the front, and A and C are still at the front. It's kind of like B and D have swapped places. So if A and C are at the front, there are metals, so they're always written first, right? We learned that from naming ionic compounds. And B and D are our nonmetals, and they'll swap places. So we've got two things that have swapped places. We are looking at a double displacement. So let's look at a real example. We can have silver nitrate and calcium chloride. The silver and the calcium are still at the front, and the nitrate and the chloride swap places. They're now bonded to a different metal. The hard part about these, and sometimes about single displacements, are we have to do a crisscross again. So not always will it be pre-balanced. Notice that we've got a Cl2 here and just a Cl here. So when they do swap places, when Ag is now going to be with Cl, we have to do a new crisscross to find out what the chemical formula is actually going to be for this. So we'd have to find Ag on the periodic table. Notice it's a 1 plus. Cl on the periodic table. Notice it's a 1 minus. And crisscross those two 1s. Same thing to find out how to write calcium nitrate. So calcium on the periodic table is a 2 plus. That's where that 2 came from, right? Nitrate, we'd go to a chart from the last lesson because that's not going to be on the periodic table. It's a 1 minus, so it gave its 1 to calcium, and calcium gave its 2 to nitrate. We put nitrate in brackets so that we could separate that 2 from showing that this entire polyatomic sticks together. So this will be a little bit harder to balance because we can see, well, the chlorines are definitely out of balance. We looked at that at the start. So do metals first, then chlorine, and finish off with your polyatomics. So 1 Ag, 1 Ag, good. 1 calcium, 1 calcium, good. 2 chlorines, only 1 chlorine. So the only way we can make these numbers match would be to put a 2 in front so that we have 2 of each. By doing that, though, we're now saying we also have 2 silvers. So we have to make sure we put a 2 here to also have 2 silvers. This 2 will also say we have 2 nitrates. That 2 works for whatever's behind, which is good for us because we have 2 nitrates over here. So everything should always be able to be balanced. If you're having a really hard time, ask me, but double check to make sure that your crisscrosses were right. Because if your crisscrosses are off and maybe you wrote just the 2 here by accident, that's going to make it impossible to balance. So double check what kind of subscripts you use for your numbers to make sure that balancing can actually be possible. Anyways, so we're not going to go too far in depth into these brackets, but a precipitate is when you form something that's solid as a product. So this AgCl with an S, meaning solid, this is a precipitate of the reaction. If you saw this in real life, you'd see like a soot, a dust, something collecting at the bottom of your test tube. So just like how we had a subgroup for synthesis, we had combustion reactions. Neutralization reactions are a subgroup of double displacement. So they're just special in a way because we'll always have certain reactants and certain products in a neutralization reaction. So here's an acid. We saw a whole bunch of acids in our last lesson. It's an oxyacid because it's got an oxygen here, right? Like it's a polyatomic with an H on the front. And so anything with an H on the front, we were saying when we were looking at acids before, would be, hey, my indicator that this is an acid. Our indicator that something's a base is that you're going to have an OH at the end, a hydroxide polyatomic ion. So H means acid at the front, OH means base at the back, those are the two things that have to react together in a neutralization reaction. And what that will always produce, that H and that OH, will form water together. And the leftovers, that Na and this NO3, this will always look different though, is called a salt. So we'll always have an acid plus a base going to water and a salt. And this is already balanced, which is nice because they're the harder ones to balance. But if I were to balance it, I'd leave my O and H's till the end. I'd start with my metal, my Na, 1 Na, 1 Na. I'm going to look at this NO3 as a group over here, instead of tying the oxygens all together. So I have 1 NO3 and 1 NO3, and then I'll look at my H's and O's. I have 2 H's on this side as well. You've already balanced this O, so only look at this O. 1 O and 1 O. So yes, it's already balanced. Awesome. So your homework is actually in this document, the types of reactions worksheet. I'm just going to go by it so we can see it. So types of reactions, it's going to be a whole bunch. I think there's a second page as well. Yes. That we're going to have to balance and then say what type of reaction it is. So if we were to do one together, let's take a look. We've got Na and Br together. We have phosphoric acid. You might think, ooh, I have an acid. Is it neutralization? But this isn't a base, right? We'd need to have OH on the back. So we have 2 compounds. And let's see what they look like on the other side. We also have 2 compounds. Still at Na at the front, still at H at the front, but now they're bonded to 2 different things at the back. Na was with Br before, now it's with PO4. H was with PO4, and now it's got the Br. So we've got a double swap. This guy is a double displacement. Let's just try to balance it, and then I'll let you do the rest on your own because the answers are posted. So the way I'm going to do it is I'm going to do my NAs first. You can do your H's first if you want because it's at the front, then Br, and do your PO4 as a group. So 1 Na, 3 NAs. So I'd throw a 3 here, right, to make sure I have 3 on each side. I'm gonna have to remember what I said because now I don't have visuals. I have 3 H's, only 1 H, so I'm going to throw a 3 here. So now I have a 3 here and a 3 here. So when I'm balancing my BRs, I have 3, and I have 3 on this side. So they're already balanced. 1 PO4 and 1 PO4. So this should be balanced with a 3, nothing written here unless you want to write a 1 or nothing, and a 3. So continue that down to the bottom. The next one looks scarier, but it's already balanced for us. We just have to take a look and see what type of reaction is occurring.